physical geology students. This is the second lecture for July the 6th, Monday, 2020. Last time we left off talking about Chapter 9, and we were talking about stress and strain. There are three kinds of stress that you can apply to rocks. Remember, stress is force divided by unit area. You've got three kinds of stress: tensional stress, compressional stress, and shear stress. Tensional stress is when you pull rocks apart, like you see here. If I took a rope between my two hands and pulled it apart, I could feel the tension in that rope. That is called tensional stress. And it primarily occurs, geologically speaking, at divergent plate boundaries where plates pull apart. Second type of stress is called compressional stress. And that's when you push rocks together, like when two plates collide. Compressional stress primarily occurs at convergent plate boundaries. The third type of stress is called shear stress, where let's say I had two. Let me give you an example. Let's say I have two plates, and represented by these two packs of cigarettes, and if they slide next to each other, then that's called shear stress. If I push these together, that's compressional stress. If I pull them apart, that's tensional stress. So those are the three kinds of stress. Stress, you might recall, can cause rocks to break. It can also cause rocks to change in shape, which we call strain. Enough stress, if it can cause it, when it causes a rock to break, will cause an earthquake. Now, next thing we want to learn about is two very important geological terms, and they are called strike, and the second one is called dip. We also want to learn about the different kinds of faults. And those include dip-slip faults and strike-slip faults. There are three kinds of dip-slip faults that we're going to talk about: normal faults, reverse faults, and thrust faults. There's two kinds of strike-slip faults we want to talk about, and those are right-lateral strike-slip faults and left-lateral strike-slip faults. And then we want to talk about one additional, let's just talk about these five. Those are the main ones for this class. Those are the five that you need to know for this class. They're 99% of faults are these. Okay? In order to understand what these different faults are like, we need to first know what strike and dip are. We must understand strike and dip. Now, some people are going to have problems with this because they have difficulty spatially in geometry. It's basically geometry. Other people who are very good at visualizing things might find this quite easy. Let's try and start off by doing it here. Here you have a stack of sedimentary beds, 1, 2, 3, 4, and 5. Now, whenever these kinds of diagrams are called block diagrams, and we're going to be working with them in your next lab. So understanding this is essential to doing your next lab. Now here you can see for this green bed, and by the way, it shows you that north for this block diagram is up. That means south is down, east is to the right, and west is to the left. Okay, so north, east, west, south. Going from here to here is northeast. Going from here to here is southwest. The strike of this green bed is drawn in for you right here. Which way is this bed striking? Well, it's striking to the northwest. We could say it's striking to the southeast, but we always, in geology, we always use north for strike. So it's this bed is striking to the northwest. And it's dipping, and the dip is always at 90 degrees to strike. It's perpendicular to the strike. It's dipping to the southwest. So the dip direction is represented by that arrow. So the strike of a bed, let me get you another picture, might make it easier here. Let's get you a nice picture here. The strike of the bed is the direction that you need to walk on to stay on this bed. So it would be this direction. And the dip is going to be perpendicular at 90 degrees to strike. We have a symbol we use for strike and dip. And this is the symbol. It looks like this. This symbol here is a strike dip symbol. If north is up like that, and east is to the right, and west is to the left, and south is down, and that's the way it's going to be for all the maps we're going to be looking at. North is always up, south is always down, east is to the right, and west is to the left. Which way is this feature striking? It is striking to the northeast. That's northeast. And it's dipping to the southeast at 32 degrees. Here you can see a stack of beds. And you can see that you have this gray bed, this orange bed, and this light orange bed. Here you can see this orange bed and this gray bed meet at this black line, which is called a bedding plane. That's the boundary between these two beds, the bedding plane. This bedding plane, if you follow the bedding plane on the surface of the earth, which is represented by this white square, then you can find the strike. The strike always follows the bedding plane. So the strike of this bed, if this way is north and that's east, it's striking about north 45 degrees east. And the dip, which would be drawn in right like this, would be to the east at about 45 degrees. I'm going to do a few more of these because it takes time before you can get used to this. Here's a block diagram. Oh, and actually, let's not do that one. This one's too hard. I don't want to start with the hardest ones. That wouldn't be fair to you. Okay, oh, here's the one that here's an easy one here. Here you got 6 beds. Beds 1, 2, 3, 4, 5, and 6. Of course, you know the oldest one is bed 1 because it's on the bottom, and bed 6 is on the top. Here's your block diagram. Here's the strike and dip for bed number 3. Notice that the strike of bed number 3 follows this bedding plane between bed 3 and 4. So it's striking, if north is up and east is to the right, it's striking to the northeast at about 30 degrees. And the dip, we draw it in perpendicular. So this bed is dipping or tilting basically southeast. Here's the strike and dip of bed 4. Notice the strike of bed 3 and bed 4 are the same in this case. Bed 5, same strike for all of these beds and the same dip. These are the strike and dip symbols for this stack of tilted beds. Let's see. I'm going to give you some examples before you do your exercise so you can get used to the strike and dip stuff. Let me see if I get another nice picture here for you. Here's another stack of beds. Notice the strikes follow the bedding planes, and the dip is perpendicular to strike and points to the direction that these beds are tilting, which in this case is to the east, to the right. Okay, now what you need to do is watch the watch the video on, let's see here, in your textbook. There's a video in your textbook that explains strike and dip. Watch that video really careful, and you will understand what strike and dip are. The lab is going to help you a lot in understanding what strike and dip is. The strike and dip can be used for any surface, any geological surface. Here's the video. Click on this video, and you'll learn more about strike and dip, and you'll also learn about the different kinds of faults. Now we want to talk about the different kinds of faults. We've got two main kinds, dip-slip faults and strike-slip faults. Dip-slip and strike-slip faults. First, let's talk about dip-slip faults. Okay, so we're talking about dip-slip faults now. Earthquakes occur at faults. Wherever the movement begins along a fault, that's where an earthquake begins. So we're going to talk about dip-slip faults first. Okay, let's take a look at the difference between a dip-slip and a strike-slip fault. Here you can see two kinds of dip-slip faults, a normal fault or a reverse fault. There's also one called a thrust fault I'll show you in a moment. But this is a dip-slip. These two are dip-slip faults, and this is a strike-slip fault. With a dip-slip fault, the ground moves up on one side of the fault after the earthquake, and the ground moves down on the other side of the earthquake. Notice that for both a normal and reverse fault, you're going to see the ground move up. It's easy for the seismologist, the person who studies earthquakes, to tell, since there's a change in elevation after the earthquake, that this is a dip-slip fault. A strike-slip fault is where the ground moves like this. There's no change in elevation. There's no change in elevation. Notice that geologists always use these arrows. These are called half arrows. They're not full arrows. They go like this and like that, and like that and like that to show which side moved. So this side moved down, so they draw a half arrow over here. This side moved up, so you draw a half arrow over here. Look at the shape of that arrow. That's the way you're going to have to draw it on your lab. Here you get this side moved down and this side moved up. And they used arrows to show which side moved up and which side moved down. With the strike slip fault, you want to use arrows to show which side moved, and this side moved this way and this side moved that way. Let's start off with talking about the dip slip and the strike slip faults first. The dip. Let's talk about the reverse and normal faults. And in order to understand reverse faults and normal faults, we have to understand what the hanging wall and the footwall are. We have to know what those are to be able to tell if is it a reverse fault or is it a normal fault. Here you have a picture of a normal fault. Here you have a picture of reverse fault. Now the way to tell which side is the hanging wall, simply imagine yourself putting the base of your fist right on the fault plane, which is this plane here, and the direction that your thumb points to is the hanging wall. So this must be the hanging wall. Because if I put my fist right on here, my thumb would point to the hanging wall. If this is the hanging wall, then this must be the footwall, right? For the reverse fault, this is the hanging wall, and this is the footwall. And they labeled it here so you can see it. So, for a normal fault, the hanging wall moves down after the earthquake, and the footwall moves up. For a reverse fault, the hanging wall moves up, and the footwall moves down. It's important to note that when you have reverse faults with the hanging wall going up like this, that means compressional stress was involved. That means the rocks were pushed together. These form at convergent plate boundaries. When you have normal faults, the hanging wall moves down, and normal faults are caused by tensional stress, where you pull the rocks apart. Now let me ask you a question. East Tennessee was formed under compressional stress. What type of faults are we going to have in East Tennessee? Reverse or normal faults? Think about it. Reverse faults. I guarantee you every fault that you look at in East Tennessee, the hanging wall has moved up. Okay, so before I get into the strike slip faults, let me show you what a thrust fault is. A thrust fault is just a special type of reverse fault. Let me show you what it looks like. So here's a normal reverse fault where this is the hanging wall, this is the footwall. The hanging wall moves up. This is a normal reverse. This is a reverse fault. Here the hanging wall also moves up, but notice the difference. That the angle of the fault plane is not steep. It's at a lower angle from horizontal, if this is horizontal. So back in the 80s, we used to call thrust faults low angle reverse faults, but now we call them thrust faults. So thrust faults is just a special type of reverse fault. They also form by compressional stress at convergent plate boundaries. Now let's take a look at strike slip faults. This is a strike slip fault right here. Notice that one side moves relative to the other without any change in elevation. So you can't identify a hanging wall or footwall for a strike slip fault. And strike slip faults are easy to recognize because they will offset features such as roads, sidewalks, rows of trees, or rivers. Notice that this river is the same as this river. This part has moved this way, and this part has moved this way to the north. So the linear features are offset by strike slip faults. Let's take a look at some strike slip faults. If you have a road and this side moves, in California this happens all the time, this side moved this way, this side moved that way. And we call this specific type of strike slip fault can be defined as either a right lateral or a left lateral strike slip fault. How can you tell? Is it a right lateral or left lateral? Let's take a look. Okay, this picture here shows it real well. This is a right lateral strike slip fault, and this is a left lateral strike slip fault. And the way you could tell, if it didn't say left lateral, right lateral here, how could you tell that this one here, what it is? Well, if you're standing on this side of the fault, and you look to the other side of the fault for a feature that exists also on your side of the fault, such as this road, which way did the road move after the earthquake? It moved to your right. So this is a right lateral strike slip fault. Here, if you look across, which way did the road move relative to you after the earthquake? It moved to your left. So this is a left lateral strike slip fault. Most famous fault in the United States, all Californians are worried about earthquakes occurring due to the movement of the San Andreas Fault, which is a transform plate boundary, you might recall, is the San Andreas Fault. Let's see if we could take a look at a picture here that, let's see, strike offset. Okay, here you can see a creek called Wallace Creek. Here's the San Andreas Fault. This creek here used to flow in a straight line, but now it's flowing on this side over here and this side over here. Is the San Andreas Fault, here's the fault, and that's the same creek. Is it a right lateral or a left lateral strike slip fault? Think about it. It's a right lateral strike slip fault. Strike slip faults occur at transform plate boundaries, where plates slide next to each other. Reverse faults, where the hanging wall goes up, occur at convergent plate boundaries. Normal faults occur at divergent plate boundaries due to tensional stress. Take a look at this. Was this formed by a reverse, normal, or strike slip fault? Well, there's no movement upwards of the land, so this must be a strike slip fault. This fence used to be the same fence. and it moved due to the earthquake. Every time that happens in Tennessee, in California, by the way, there's a law. The law is a surveyor has to come here and mark this after the earthquake, this part of the fence and this part of the fence, and then they take the midpoint between the two, and that's a new property line. But anyway, is this a right lateral or a left lateral strike slip fault right here? You look across, the fence moved to your right after the earthquake. It is a right lateral strike slip fault. We're going to get practice in identifying the different kinds of faults in your next lab. We'll call it quits for now, and we'll do another video later.